Today's lesson is going to now focus on the rigid transformation reflections. Reflections are when figures flip across a certain line on the coordinate plane. Remember, since reflection is a rigid transformation, everything should end up same shape and same size. All right, first of all, let's make sure that you understand each line that is on the coordinate plane. The axes are easy to understand. Most kids always get that. If you are looking at this line that I'm tracing in red, that's known as the y-axis. Then let's see here. Let's trace the x-axis in green. But then there's all these other lines. Let's go ahead and change to, I want something that's going to show up. I'm going to do purple. So let's first look at this line right here. Notice it runs horizontal with that y-axis, but in our linear functions unit, we talked about the fact since it's parallel was the word I meant to use, since it's parallel with the y-axis, it actually never touches the y. And that was always an equation that said x equals something. We lost our y values because of the fact there is no y-intercepted, it won't touch it. So on that line, on those vertical lines, you've got to figure out what is the x value always equal to at each one of those points. Well, that's where x is always 1. So any vertical line that's not the y-axis on the coordinate plane is going to be something like x equals 1, x equals 2, x equals 3. So let's pretend like they tell us that we're going to reflect across x equals -3. Well, I'm going to tell you the first thing you have to do is trace that line. So since it's x equals, you know it's going to be vertical. You find -3, here it is. So you're going to trace this line right here where all those points are always x equals -3. All right, now I'm going to switch colors. Let's try, this is kind of an orangish looking color. But now let's look at a horizontal line, like maybe this one right here. Notice that one never touches the x-axis, so therefore there would not be an x-intercept. We would lose our x values. That's an equation that's going to be y is always equal to something. Well, we would have to find what are all these y values always. They're consistently always 2, so that is where y is equal to 2. So any horizontal line that's not the x-axis is going to have an equation that says y equals something. Okay, now let's talk about the fact that I said except for not the x-axis, not the y-axis. What I mean by that is when your reflection is actually the x-axis or y-axis, they will definitely tell you that. But let's find the equations for those. Since I'm already in orange, let's look at the y-axis. Notice that, or I'm looking at the x-axis, the y value right here is y equals 0. So actually the y-axis can also be called y is always 0. So now let's use some process of, or not elimination, but like some deduction here. What would the y-axis always be? Well, vertical lines are always x equals a number. That would always be, that could also be known as x equals 0, but they won't give you like that. They will tell you specifically the axis today. All right, so let's look at how this is done. If you're asked to reflect something across the y-axis, first step is to trace that axis. Now, a reflection means it's going to flip across that line, okay, and it's going to be equal distance. So that's why my next step is going to be count. How far is it from that line? It's 2. So my reflection is going to be 2 away on the other side. Q prime would be right there. I just make sure that I'm keeping the reflection on the other side equal distance away from that line. Let's look at this one. X equals 2. I have to first figure out where is that line. Well, x equals means it's going to be a vertical line. So x equals 2 is right here because that's where positive 2 is. All right, so S again, it's 2 away from that line. So I'm going to go 2 away from this side and put S prime is right there. All right, let's go ahead and do a triangle. Just like in translations, we're going to focus on the vertexes and do them separately, then draw our triangle. So let's first find x is 1. If it's an x equals, that's a vertical line where x is 1. Let's first talk about this w, because w touches my line of reflection. When a point touches your line of reflection, that means it is not going to actually move. So I already know that w prime is right here. I need to now move the other two. So let's do x prime. X is 1 away, so I got to go 1 away on the other side. There's x prime. Now let's do y. Y is 2 away, so I'm going to go 2 away on this side. There's y prime, and now we just simply draw in that triangle, and we have the triangle reflected. Let's do one across y equals now. Remember, if x is a vertical line, y equals is going to give us a horizontal line. So I got to trace the line y equals. Here it is. And now I'm going to do each point. Notice on this one, the line goes through my triangle. And so now I have some points above it and some points below it. That means the ones that are originally above are going to drop below it. The ones that are originally below are going to drop above it. So let's go ahead and start with any one you want to. I'm going to start with W. So W is above it. That means it's going to go to below it, equal distance. So it's got to go below it to W will be right here, W prime. Now I'm going to do X. X is originally below it, so it's got to go above it, equal distance. So 1 away, there's X prime. Now let's do V. V is original below the line, so it needs to go above the line. It's 2 away, so go 2 away above it. There's V prime. So now all I have to do is trace that triangle, and that's a very interesting reflection, isn't it? They get pretty interesting looking when the line runs through the figure. All right, reflection across y equals 1. On this problem, this is where they're asking us to write the coordinates, the ordered pairs. So let's find y equals 1. That's going to be a horizontal line right here. So the reason I'm doing these kind of separate is I really want to lead you into tomorrow's. So I'm going to first write out what's the order pair. Oops, that's not, shouldn't be a prime. What's the order of pair for just k? K right now is where x is 3, and then the y value is -3. We're going to reflect across y equals 1. So let's go ahead and do it. It's 4 below this line, so I need to count up 4 above it. That puts it right here. Okay, and now I want to write out those order pairs and show you something. All right, so the x is 3, and then the y value is now 5. Notice when you are reflecting across a line that says something like y equals, what values actually end up changing? The y values do. The x values did not change at all, and it's because it's just a movement of up or down. Okay, let's go ahead and look at this one. X is -2, so I'm going to trace that line. I'm going to write out where t is. T is right now at -5, +1. Let's find t prime. I am 1, 2, 3 away, so move 3 away over here for t prime. Let's write out those order pairs. It's now at 1, 1. Notice when you're reflecting across something that's x equals, what changes? The x values change. The y's stay the same, and it's because that reflection is a horizontal reflection, and our x's is our horizontal movement, so that's what changes. All right, now let's go ahead and find the rule. So to find the rule, what you're going to do is find the middle of every vertex and its counterpart, its prime. So I'm going to focus on m's. I see m and m prime, exactly the middle of those is right here. So I'm going to mark it. Now let's look at k's. I got k prime and k, Exactly the middle of those is right here, and then L did not change, so I just trace above it. What I've now done is I've traced 3 points that are on my line of reflection. So let's go ahead and draw it and look at what that line is. That line is the x-axis, otherwise known as the y's are always 0. So let's think about what we just looked at. If I were to write out these ordered pairs, I would notice the y values change when I'm reflecting across the x-axis. The x values will stay the same. Let's go ahead and look at this one. Let's do in between. So in between the k's, it's right here. In between the j's is right here. In between the i's is right here. So my 3 points are falling on the y-axis. So my rule could be that's a reflection across the y-axis, otherwise known as x's are always 0. So let's think about that. That tells me the x values, if we were to compare the ordered chain or order pairs, the x values are changing. The y values are not going to change. They're going to stay the same.